Assalamualaikum and a very good morning to everyone. Today I would like to share with you guys about hydrogenation of vegetable oil for margarine. Before I start my sharing, I'd like to thank you my group members for their hard work in finishing this project. So, without wasting any more time, let's start the presentation. Okay, before we go a little deeper about the hydrogenation of vegetable oil, I'd like to share a little bit about the history of the margarine making. Under this topic, I will talk about the traditional making process and the ingredient used to make the margarine. In our society, margarine is more preferred than butter because of two simple reasons, which are its lower price and has longer shelf life. The popularity of the margarine rise rapidly as vegetable oil-based products become a trend around the second half of 20th century. During the old days, margarine was produced by using the traditional chilling drum. The interior of chilling drum is first cooled by ammonia or freon evaporation. Then, a thin layer of emulsion is applied on the cooling surface of the chilling drum. Without agitation, the cooling of emulsion is also able to take place rapidly. The crystallized emulsion is then scraped off as some thin flakes. These thin flakes are allowed to rest in the silos for a couple of hours until the completion of crystallization process. For the final step, these margarine flakes are kneaded in the vacuum kneading unit until a margarine block is produced from air. There is a documentary video about margarine making process in 1940 which I want to share with you guys. Please enjoy.
Whale oil from the cold Antarctic seas. Coconut, groundnut and palm oils extracted from nuts grown in hot lands. Here, ending their long journeys, they arrive at the creamery in tankers. Weighing the oils in their correct proportions is the start of making a batch of margarine. This man is turning on a tap at the end of a pipe leading from one of the storage tanks. The oil flows into a small tank that forms part of a weighing machine. Hardened oils are solid at room temperatures. To keep them liquid, they are stored in tanks where they can be heated above their melting points. The whale oil is run off into a further tank and hardened groundnut oil is weighed. This is followed in turn by palm oil, coconut oil, and groundnut oil. The nuts that are the sources of these oils are very important. These oils are pumped into a temperating tank which has a surrounding hollow space into which either steam or iced water can be run in order to control the temperature. Adding emulsifier to the mixture of oils comes next. This emulsifier may be either lecithin or abricol. Margarine, like butter, is an emulsion of oil and water. Without the emulsifier, these two liquids will not mix. Paddles rotating in the temperating tank thoroughly mix the contents, which at the same time are brought to a temperature of about 40 degrees centigrade. While the temperature of the oils and emulsifier is reaching 40 degrees centigrade, the next operation is mixing salt with iced water in another tank. The salt goes in, and the paddles go round to help it to dissolve in the water. When enough iced water is in the tank, the man turns off the tap. Churning is just as necessary in margarine making as in butter making. The first stage is churning cultured milk and iced salt water. This bucket contains a special milk culture made with lactic acid bacteria. The margarine gets its butter flavor from this culture. Into the churning tank goes the culture to be followed by the iced water led in through a pipe. Culture and water are churned for a few minutes. The mixture of oil and emulsifier are run into the same churning tank. The whole is churned for about 10 minutes. From the churn, the mixture runs down a pipe and is forced through a series of perforated blades, rapidly rotated by an electric motor. Here the transformation takes place and emulsion is produced. To this emulsion, the remaining ingredients are added: flavor, vitamins, and colour. These three go into the emulsion in the churning tank. Vitamins are among the last substances to be added because they tend to be destroyed by agitation. A very gentle rotation of the paddles gives a final mixing. The emulsion, still warm, now requires cooling. From the churn, the warm liquid is pumped through pipes to a small reservoir as long as and fitted close to a revolving drum. Here is the liquid flowing into the reservoir. The outflow from the reservoir is controlled so that as the drum rotates, a layer of emulsion 1/6000th part of an inch thick is deposited on it. The drum is cooled from within to a temperature of about 2 degrees centigrade. The deposit makes one rotation, during which time it becomes frozen hard. Just under the reservoir is a knife blade, which scrapes the now solid margarine from the drum. It falls in flakes onto a moving belt. This belt takes the margarine to the top of a chute. There remain now only two processes, kneading and packing. Down the chute, the flakes drop to the kneading machine, inside which is a big screw, in shape rather like that in a mincing machine. The screw forces the margarine along until it is extruded from the end and falls into a stainless steel trolley. The colour, now a rich gold, stands out against the white paint and stainless steel of the creamery. The margarine is taken in the trolley to a cool room, where it stays about 2 hours. After this time, it is then ready for packing. It is fed from the trolley into a packing machine. This machine automatically separates margarine into half-pound pieces and perforates the date on the wrapping papers. This enables a check to be made if, later, anything proves wrong with the margarine. The machine wraps up the pieces, delivering a constant stream onto another moving belt.
Okay, now back to our traditional process. Actually, there are several disadvantages present. The first one is the difficulty to control the hygiene during the process. This is because the scraping part of the process requires many workers. This means that to control the hygiene for each one of them will be very difficult. The second one is the limited use of chilling drum in today's industry, as it was replaced by continuous scrap surface heat exchanger crystallization method, or SSHE. Okay, now let's talk about the change in ingredient throughout the years. When margarine first introduced to the world, most of the manufacture is from beef fat. After that, it changed from beef fat to edible animal or vegetable oil such as corn and sunflower oil. However, the liquid part is made from milk, water, or liquid protein mixture derived from soybean. Okay, go on to our second topic, which is hydrogenated vegetable oil. In this topic, I will talk about why do the hydrogenation of oil is needed and also about the hydrogenation process that involves. So, why is hydrogenation of oil needed? We all know that hydrogenation converts liquid vegetable oil into solid or semi-solid fats. As the degree of saturation fat change, the melting range will also change, which the liquid oil becomes semi-solid. In baking, this form of vegetable oil is desirable as it gives smoother texture. Besides, it is also way more cheaper than animal fats with wide range of consistencies. Hydrogenated oil also increase oxidative stability of food and increase the shelf life. We already know why hydrogenated oil is needed. So let's move on to the process, which is hydrogenation. First of all, I like to talk about the reaction. Hydrogenation is a process where exposing unsaturated fatty acid to hydrogen gas in the presence of a catalyst and to be converted into saturated fatty acid. When naturally occurring, it has the effect of straightening the change and changing the physical properties. During hydrogenation, unsaturated fatty acids, which are normally found as the cis isomers at the double bond, are changed to a trans double bond. However, if the hydrogenation reaction is stopped halfway through, a mixture of trans unsaturated fats and fully saturated fats is obtained. These products are partially hydrogenated oils and contain a large amount of trans fat. If the hydrogenation reaction is allowed to proceed until the final stage, a hard and completely saturated fat is made. They are called fully hydrogenated oil and contain a very small amount of trans fat. Now let's take a look at the catalysts that can be used. The catalyst can be divided into two columns just like in the table. The first column contains platinum, palladium, rhodium and ruthenium, while the second column contains nickel such as Arani nickel and Urushibara nickel. Each of the column has different type of properties such as different operation temperature and pressure. After we have learned about the catalyst, next let's talk about the type of reactor. For the process, batch type slurry hardener reactor is used. The reason is because it is easier to control in a batch reactor. It is also possible to reach high selectivity and to adjust the process to different demands on the product. For a reactor to function properly, it has to meet the requirement condition. For this process, the oil has to enter the reactor under vacuum. Aside from that, the oil needs to be heated up to 85 or 95 degrees Celsius to remove the dissolved oxygen and moisture from the oil. This process will take about 15 to 20 minutes. In order to remove the dissolved oxygen and moisture from the oil, reactors can have oil preheaters that heat up the reactor feed. Then the catalyst is added about 0.01 to 0.02% of the oil, and the catalyst used is basically nickel basis. The next topic that I want to share with you guys is the impact of the hydrogenation process and product to society. Because of the long shelf life advantage, margarine that undergoes hydrogenation is preferred by people and companies. Why? This is because they can save a lot of money. The hydrogenation also improves the texture of the margarine, which increases the stiffness of the product with margarine, which is desirable in making food appealing to attract customers. However, there is a bad side about this process. Trans fat is always unhealthy no matter the amount it is consumed. This is because it can raise bad cholesterol level in blood. Besides, it also poses a cardiovascular disease risk. And lastly, it can slow the microcirculation of blood through human brain, which is dangerous. Move on to the next topic, which is the daily product that contain hydrogenated oil. The example of our daily products that contain hydrogenated vegetable oil are daisy margarine, hot chocolate malt drinks, and also coffee made from Nestle. Our last topic for this presentation is the alternative engineering methods for margarine without hydrogenated oil. In this topic, I will talk about the interesterification process. For interesterification, the process is to remove fatty acid chains in triglyceride from glycerol backbone and reattach randomly. It can be performed using either enzymatic or chemical interesterification. For chemical interesterification, the predominant form use change crystal form of oil to produce desired solid fat content curve. For enzymatic interesterification, the desired array of triglyceride produced through temperature manipulation. For catalysts involved, the chemical interesterification use the alkali metal such as sodium, potassium and the alloy and alkoxide. For enzymatic interesterification, the catalyst used is lipase. For the reactor, if we look at the table here, the chemical interesterification uses the batch reactor with agitator including heating and cooling, sparging and vacuum steps. For the enzymatic interesterification, the reactor use is the plug flow. Each of the type of interesterification has their own operating condition. One of the example is for the chemical interesterification, which the oil need to achieve certain quality standard. Besides, if the alkaline catalyst used, special care should be taken. For enzymatic interesterification, the one condition is that the lipase used is under virtually anhydrous condition where the temperature is up to 70 degrees Celsius. Okay, let's talk about the impact of interesterification and product to society. Just like the hydrogenation, interesterification also has the impact to society. The product produced by this process can be free of trans fatty acid. It also can produce margarine with softer product which have low melting point and without separating process. Waxy translucent for coating purpose also can be produced using this process. And also lastly, it can produce confectionery fats with high quality. And yeah, seems like that's all for me. Thank you very much for lending me your ears. Hope we meet again. Bye bye.